In the last video, I introduced you to the concept of a formal language in general, and I explained that it was a purely syntactic concept. So now I want to introduce the syntax for the formal language that we'll be working with, which is typically referred to as propositional logic. So like any formal language, the first thing we're going to need is an alphabet, or a set of symbols that are allowed in the language. And we're going to start with capital letters from A to Z. So we have the 26 capital letters. Those are going to be referred to as simple sentences for reasons that will become clear later. The next set of symbols that we have are these two funny guys that those are called parentheses. So there you go, parentheses. You learn something new every day, right? Actually, these are going to be used in our system as grouping symbols. The next thing we have is this kind of funny squiggly mark, which we call tilde. Then we have this dot-looking thing, which we call dot. The next symbol looks just like a V. We're going to call that wedge. And then we have this odd sort of sideways looking U, which we call horseshoe. It looks kind of like a horseshoe. And finally we have these three lines. It looks like an equal sign but with an extra line. That's called triple bar. These five symbols, these last five, are referred to as operators. So we have simple sentences, grouping symbols, and operators. For our purposes, since we're communicating online through computers, I think it would be best if we had a pure ASCII system. ASCII is the standard symbols that you have on your keyboard, and you'll see that we've got a couple symbols up here that are not easily accessible on your computer. You can actually find them, but it's not easy. So it's unfortunate to have two sets of symbols, but I promise you this is going to be helpful, and we don't need to change things very much. The simple sentences and the grouping symbols are going to be exactly the same, and then we're only going to change a few of the operators. The tilde, that's on your keyboard in the upper left-hand corner, so we can keep that as it is. And then the dot, instead of using, let's just use a period, a regular period for the dot. And then for wedge, we can actually just use a lowercase v for the wedge. It looks exactly the same. Now horseshoe, that's not easily accessible on your keyboard. So let's use this symbol. It's a dash and then a right corner bracket, and we can call that arrow. Okay, so the dash is on your keyboard, the right corner bracket is down in the lower right corner next to the question mark. And then instead of the triple bar, we can use a double arrow where we'll put a left corner bracket followed by a dash and then the right corner bracket. So now we've got an alternative, a few alternatives here where we can use just the standard symbols that are on all of our keyboards. So we have our alphabet, and as I explained in the video on formal languages, the next thing you need for the syntax of a formal language is rules that tell you what counts as a sentence of the formal language. And the first rule in this case is going to be that nothing is a sentence unless these rules say it is. And I hope it'll become clear soon why we have a rule like that. The second rule is that each simple sentence is a sentence. So I said it would become clear why we're calling them simple sentences. That means at this point we have, let's see, A, B, C, D, up through Z, we have 26 sentences, right? What counts as a sentence? Well, A, right? That counts as a sentence. How about just the letter B? Well, that's a simple sentence, so that counts as a sentence too. W? Sure, we could go on not quite all day. We could name 26 of them, right? How about this? If we have AW, is that a sentence? Well, the first rule says that nothing is a sentence unless the rules say so. The rules say that A is a sentence and they say that W is a sentence. But there's nothing here that tells you can put A next to W and that will be a sentence. So that is not a sentence. Now, how about this? Once again, the rules say that nothing else is a sentence unless the rules say so. So although A is a sentence and W is a sentence, you can't put the two together and make a sentence, and you can't put like tilde between them and make it a sentence. You can't do anything with any of the operators yet until I give you more rules that say that things with operators are sentences. Now, in order to introduce the rest of the rules, I'm going to have to use a device called a metalinguistic variable. And it sounds a little intimidating. It's not quite as bad as it seems. It's traditional to use lowercase letters starting with P as metalinguistic variables. So we have P, Q, R, S. I'm not going to be as pedantic about what I'm using as metalinguistic variables. So I will probably never need more than 4. It's important to notice that I'm using lowercase letters as metalinguistic variables and uppercase letters as part of the system I'm working with. So these metalinguistic variables are not part of the formal language. They're used to talk about the formal language. A metalinguistic variable stands for an arbitrary sentence of the system, but the variable itself is not part of the system. So when I use a lowercase p, for example, the idea is that what I say about this p is meant to apply to any sentence of the language, anything that is a sentence of the language. So for example, we said A is a sentence of the language. So p could be A. P could be B, or P could be W. So these work in a way that's pretty similar to variables in math that you're used to using all the time. You're used to using an X, Y, Z. It stands for some number, some arbitrary number. This one's metalinguistic, though, because it stands for some sentence. So now let's go back to our is it a sentence game and ask one more. What about P itself? Is that a sentence? The answer is it's not a sentence. Metalinguistic variables are not part of the formal language. Now, if you're kind of confused on this, let me go into it in a little more detail. Philosophers often make a distinction between use and mention when we're talking about linguistic expressions. To take a first pass at getting this distinction, let's say that we have three names written down. So we have the names Al, Bob, and Carl. And then I tell you to get rid of Carl. What are you going to do? Maybe you're going to erase Carl's name. Well, that isn't what I asked you to do. I said to get rid of Carl. And, maybe I'm going to pay you a lot of money if you get rid of Carl, and you just erase Carl's name. Sorry, you're not getting paid because Carl is still there. You just erased his name. So the distinction between use and mention has to do with the fact that Carl is a person. But if we want to talk about the word Carl, we will put that inside of single quotes. So Carl in single quotes is a name. We would still pronounce that Carl, which gets confusing, right? Because I say Carl is a person, but Carl, right, with the quotes. Carl is not a person. Carl is a name. I might say I saw Carl last weekend. He was walking his dog in the park. But if I say I saw Carl last weekend, I might follow up by saying it was written on the bathroom wall or something like that. So there's a difference between Carl, the person, and Carl's name that we don't pronounce. And that's the cause of the confusion here. When I use the word Carl, it refers to a person. But when I mention the word Carl, I'm talking about the actual word. So now we have this distinction between use and mention. Metalinguistic variables are actually used to refer to sentences of the language, not mentioned. And so it's metalinguistic because it's a linguistic expression that is used to refer to other linguistic expressions. So suppose we had a word to refer to Carl's name, to, Carl in quotes. We could call it Andy or something like that. Metalinguistic variables are sort of like that, except that they are also variables, which we don't use very much in everyday language. We do have the expression John Doe, right, which refers to an arbitrary person, right? You say there was a John Doe walking down the street or something. John Doe was walking down the street, and then John Doe met, someone else, and so on. I suppose we have sort of a metalinguistic variable in ordinary language. It's John Hancock, right? When you don't know someone's name, but you need their signature, you ask for their John Hancock. I suppose I'm not sure if that's referring to their name or if it's referring to a signature. Those might be different. But it seems pretty similar to what we're doing when we have metalinguistic variables anyway. So when I say that P is some arbitrary sentence like A or B or W, I'm not mentioning P. So I'm not saying that, quote P, end quote, is a sentence. P, that symbol, is not a sentence. But when I say P, I'm referring to a symbol, some arbitrary symbol, that is a sentence. So that's the concept of metalinguistic variables. Now, I'm going to use a metalinguistic variable to introduce a new rule of the system. And the rule looks like this. It says, if P is any sentence, then tilde, that symbol, followed by P, is also a sentence. You can think of this rule as introducing a sort of construction process for symbols of the system, for sentences of the system. So you have sort of a form of the construction process where you take some sentence, P, it could be any sentence, and what you do is you just put a tilde down on the left of it, and then that gives you a new sentence. So what we can now do is substitute in any sentence that we want for P, anything that's a sentence, and follow this process, and we get a new sentence. So we generate sentences. For example, I can substitute in A for P, follow this process, and what do I get? I get tilde A. I can do this with anything that's a sentence. I can do this with B, I can do this with C, right? Z, anything. So I'm going to take B and I'm going to create tilde B. I'm going to take W and I'm going to create tilde W. So we have some new sentences now. Tilde A, we said, is a sentence. How about tilde Y? Well, that would be a sentence too. Let me ask you this. How many new sentences do you think we have added to our system? Well, there are 26 letters. You might be thinking that's a tilde in front of each one of those is another sentence. So 26 more sentences. I guess we now have 52 sentences. But in fact, there are more. How does that work? Well, look again on the right-hand column. We're asking if these things are sentences. And we said tilde A is a sentence. If tilde A is a sentence, that means it's eligible to be run through this construction process that we're talking about. Remember, anything that's a sentence can go through this process. So if P can be any sentence, and tilde A is a sentence. So we can substitute in tilde A for P and go through the process. What's the process? Well, you put down a tilde on the left and then put down whatever your sentence is. So I'm going to put down tilde and then tilde A. So I get tilde tilde A. That's right, I can apply this rule to sentences that come from previous applications of the rule. So tilde tilde A is a sentence. I could now put tilde tilde A into the process and add another tilde, and I can add another tilde, and I can add as many tildes as I want. So, if I have tilde 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 A, yes, that's also a sentence. So now, how many sentences do I have in my system? The answer is the number of sentences is infinite. So we have now infinitely many sentences generated by our finite alphabet. Hopefully at this point you're starting to get an idea of how the syntax of a formal language is generated, and in the next video I'm going to show you the rest of the system which uses the remaining 4 operators.